Hi, cheers. I'm back. I stopped in the midstream there because I made a mistake and we erased it. So what we're doing now is checking for interval convergence of natural log. And we know that from a theorem that we learned one of these days, and they're all a blur now because it's all the same day for me, that the interval of convergence is going to be from 0 to 2, some sort of 0 to 2, but we have to check our endpoints. So let's check the endpoints. When you plug in x equals 0, you get the series negative 1 to the n, negative 1 to the n plus 1 over n plus 1. Combine these two using rules of exponents that you may have forgotten. Ms. Basani, what do those exponents add up to?
2n plus 1.
Tell me about 2n plus 1.
It's an odd number. So
negative
1 to that 2n plus 1 is going to be negative 1.
Oh, always? It won't even change ever?
It won't even change ever.
It will not be changing ever. Okay. And then tell me about the behavior of this series, negative 1 over n plus 1. Does it converge?
That converges because it's basically a alternating harmonic. Let's call it an alternating general harmonic.
Is it alternating, Basani?
It's not alternating. It diverges.
It diverges.
Because it's a harmonic.
It's a harmonic, but it's a negative harmonic. So that diverges. So we're going to go, no. Okay. Next, let's check x equals 2. So when x is 2, we have negative 1 to the n. What is 2 minus 1?
1.
To the n plus 1.
1.
Let's not even write it down.
Oh, there's the alternating one. That one converges.
Okay, it converges conditionally, but we don't care about that. We just care that it converges, right? Done.
Oh, how interesting.
Yeah, so there you go. Is that fun?
Yeah, keep going.
Let's see if we can do one more before we have to stop our the next vid. Okay. Arctangent, are you kidding me? I don't know how to do arctangent, and also it doesn't look anything like cloud over 1 minus heart. But
what about
what about what?
What about its derivative?
This? Is this the derivative of arctangent?
Sure is.
Does that look like 1 over or cloud over 1 minus heart?
Yeah.
So let's write it one more step for people who are tired right now. And make it into a series, which we should make into this series.
Nice.
Which, if we write it out, starting always at n equals 0, I'm getting lazy, folks, but geometric series always start at n equals 0, or this sum would not be true. That is a fact. Okay. So I'll get Basani to help with this because I can't do these.
1.
And then?
Minus x squared plus x to the 4th minus x to the 6th. Dot, dot, dot.
Okay. This series is a polynomial approximation of not arctangent, mind you, but the derivative of arctangent. What's the next move?
Integrate!
Okay, so we're going to integrate 1 over 1 plus x squared, which means we are integrating, I'm going all the way to my last one because it's pretty, we're integrating this, and what we get is, this is a constant, don't mess with it, it's, did I lose my series? I need a series here. Series. Okay, so we have a series, negative 1 to the n, which doesn't change. The integral of this is, remember, you just do the power rule. 2n is a number. Don't start thinking about what we used to do by plugging in the n plus 1. That is not what we're doing now. We are adding 1 to the exponent. X to the 2n plus 1 over 2n plus 1. Woo.
Oh.
So that, let's write out the terms. See if it works out.
Yeah.
So first
1.
term.
No, x. Folks at home, I'm cheating by just taking the antiderivative of each of the terms of the polynomial.
That is, but you're not supposed to be doing that because you're
I know,
supposed to be
x
checking
minus x cubed over 3. I got you.
When
I'm
we plug
plugging
in
1
1
now.
do we actually get x cubed over 3? Because I want you to be like,
do.
oh my gosh, look, that's the antiderivative, not, oh, I'm going to do the antiderivative.
I totally did.
Okay, are you
Yes,
sure? Are you
I'm
cheating?
positive. 2 times 1 plus 1 is 3.
And what happens, does this work when we put in a 2?
Yeah, so positive
Yes.
and then 5s.
Okay, so look, this is crazy. This is lining up perfectly, antiderivative, antiderivative, antiderivative. It's not crazy at all, right? This is what the point is that's why we're integrating with a series so that we don't have to integrate term by term, but it's working. So that looks like, I haven't so let me summarize that really quick here.
Folks
So-
at home, memorize this.
This is arctangent. Yeah, this is going on our memorize list next week. So arctangent of x is the series why am I rewriting this? Which is equal to this plus forever. And so I'll come to my next slide in a second for like a quick summary. Will you check my time?
You're at 6
Everyone
minutes.
say hi, Miss Ani. As she sticks her face, hi. Okay, look. So we do get a little confused when we're doing this, and we're like, wait, like we've been doing this for 7 days, and we've forgotten what the point of all of this is, and it's really fun, but why are we doing this? Remember, your calculators at some point didn't know how to do arctangent, or probably still don't know how to do arctangent, and so they're programmed with some sort of series. It's not this anymore because it's more sophisticated, but they're programmed behind the scenes with a series that's approximating arctangent. Who is doing that work? Mathematicians are doing that work. Who's working for Texas Instrument? Mathematicians like you who are going to get degrees in math are working for Texas Instrument. They're writing programs that are going to give very close approximations of arctangent. Your calculator does not know what arctangent is, but it can do this. It can plug a number in to a series. So if you want to see a really good picture of this on your calculator, go and graph these two. Did I do the interval of convergence? I don't think I did. Go graph these two and speculate about what the interval of convergence is for arctangent, and maybe go look in your book and we'll see if it's there. I don't think I even have notes on what it is, but I have a feeling it's for all x. I don't know. So look at these two graphs and see where they converge. And that's the end of that whole lesson. Thank you so much.